Section 3.2, Day 1, using algebraic methods to solve linear systems. Please write down the essential question. How can I solve systems of equations by substitution? Who uses this? Zookeepers use algebraic methods to solve systems of linear equations that model mixtures of animal foods. So in the last section, we talked about if we graphed two lines and they intersected, their solution is the point where they intersect. However, when we look at a graph that's in front of us here, as we look, they're not intersecting at nice integers. They're intersecting at decimals. And when that happens, using a graph is harder to find the solution. So therefore, we have to use this method, which is called substitution. Right there. Remember, the solution to an independent system of equations is an ordered pair. You need to find an x value and a y value. Example 1. We're going to use substitution to solve the system of equations. I'm given two equations, and I'm going to walk through the steps. Step 1, we are going to isolate one variable, x or y. We're going to pick one of the equations and isolate. Well, let's talk through that. Y equals 2x minus 1 and 3x plus 2y equals 26. The y is already isolated in that first equation. Y equals 2x minus 1. So that one's already set. Step 2, we have to substitute the answer in step 1 into the other equation. So let's go down here and let's call this our step 2. Give us more room. The other equation that we did not use was this one. So what I'm about to do right now is I am going to take this equation right there, and everywhere there is a y, because that's what it's saying, y equals that, I'm going to plug the 2x minus 1 in. So let's do that. So we have 3x plus 2. And remember, whenever we substitute, we use parentheses. So what I'm plugging in there right now is what I said from above, the 2x minus 1. So we have 3x plus, we have to distribute that 2. That gives us 4x minus 2 equals 26. Combine like terms on the left, 3x plus 4x is 7x. And then I'm solving for x. So we add 2 to both sides. We get 7x is equal to 28. Divide by 7 on both sides, x is equal to 4. We have our x value. We now have to finish up and look at step 3. We need to substitute the x value into one of the original equations to solve for y. So we found x, so now we're going to take x and plug it in to find y. And it doesn't matter. We can plug it into either of them. Well, guess what? I would for sure plug it into this one. So what's going to happen here, and this is kind of an always, whether we choose to isolate x or y, when we get to step 3, we're always going to be plugging in either our x value or our y value that we found in step 2 into this equation in step 1. All right, so let's go like this, and let's call this step 3. And the equation I'm going to use is y equals 2x minus 1. And we know that x is 4. So I'm going to take that 4 and I'm going to plug it right there. So y equals 2. That's 8. So y is equal to 8 minus 1. Y is equal to 7. We just answered this question and we have solved the system of equations. And our solution is an ordered pair. It's an x and a y, 4, 7. That right there is the solution to the system of equations. Now, these numbers are nice whole numbers, natural numbers, integers. So if I would have graphed both of these lines, they would have intersected at the point 4, 7. We would have got the same answer. All right, example 2. We're going to use substitution to solve the system of equations. So here in example 1, there was an equation where we had a variable already isolated. It was y. Here we do not. So now what we have to do is we have to look at both of these equations right now and decide which equation is going to be easier to choose to isolate one of the variables. Well, if I look at the green one, the y is already on the right side all by itself. So if I took the 2x minus 2 equals negative y, and I can switch that around to look like that, I need y, not negative y. So all I have to do is divide everything by negative 1. So that's positive. 2 divided by negative 1 is negative 2x. Negative 2 divided by negative 1 is a positive. Here is my step 1, done. So now I'm going to go to step 2. And the equation I did not use, so I used that one. I did not use the 5x plus 6y equals negative 9. So that's what I have to use. And I have to take this y value, and I have to plug this whole thing in for y. So I have 5x plus 6, and in place of y, I plug the negative 2x plus 2. So what I did is I grabbed right there. That's what this is right there. That's what y is equal to. So 5x plus, we distribute the 6, which is negative 12x plus 12. I'm going to combine like terms. So 5x plus a negative 12 is a negative 7x. I'm going to minus the 12 on both sides because I'm trying to solve for x here. Negative 9 minus 12 is a negative 21. And divide both sides by negative 7. I get x is equal to 3. I have my x value. I now need my y value. Well, I said go back to step 1 right here and take the x value and plug it in to the step 1 equation. So that's what we're about to do. That's what our step 3 is. I'm going to take my x equals 3 and I'm going to plug it in right there. So y equals negative 2. Y equals negative 4. We just created an ordered pair. And the ordered pair we just created is 3, negative 4. That is the solution to the system of equations. Again, if I graphed these two lines right here, they would intersect at the point 3, negative 4. Example 3 we're going to do in class, and here are your video questions. Pause the video, read through them, use substitution to solve the system of equations. We already did an example, and use substitution to solve the system of equations. Number 1's multiple choice, number 2 is not.